Okay, we're looking at imaginary and complex numbers right now. This fits into the unit we've been studying because we've been talking about radical expressions and radical equations, and imaginary numbers are, well, square root of a -1. It's something that was developed in mathematics to answer the question of what is the square root of -1. And there was a time when the mathematicians didn't have a number for that. And there was also a time back long ago when mathematicians didn't have a number for the answer to 5 minus 8. It was thought to be impossible. But the reality is, we know now that we can represent that with a negative number. And imaginary numbers are similar in that they help us answer the question of what is the square root of a negative. So what we're looking at here is simplifying first, then multiplying will come later, with some adding and subtracting, of course, as a part of that in between. Okay, so the first thing is, well, if we're looking at the square root of a negative, we can break that down into the square root of -1 times the square root of 25. And then some things we know, like square root of 25, that is just 5. And then square root of -1, well, imaginary numbers are defined. I is defined as the square root of -1, so we can write I. So that is just I times 5. We would typically write that, though, as 5I. Sometimes it doesn't work out quite as nicely as that, but we'll follow the same idea. So we've got the square root of -1 times the square root of 63. Square root of -1 is just I. 63 we could break down into the square root of 9 times the square root of, that would be 7. Square root of 9 we know is 3, so we would have 3 times I times the square root of 7. So basically, whenever there's a negative underneath that square root symbol, we're going to be able to take that out and put it in front as an I. All right, so that's basic simplifying for imaginary numbers. Next thing we'll look at is adding and subtracting complex numbers. So complex numbers have two parts. They have a real part, which is the first thing. We usually write that first. And then the imaginary part, which is the part that has the I attached to it. So in 8 plus 2I, 8 is the real part, 2I is imaginary, 4 is the real part, -3I is the imaginary. So when we're adding and subtracting complex numbers, we're just combining the reals with the reals and the imaginaries with the imaginaries. So 8 plus 4 would be 12. And then positive 2I minus 3I would just be minus I. So it's really just kind of like combining like terms when writing or adding and subtracting complex numbers. All right, so this subtraction, the only difference is we need to remember to distribute that subtraction to both terms. So let's rewrite that as minus 7, and then minus a negative would be plus 5I. So it's 14 minus 3I minus 7 plus 5I. 14 minus 7 is 7. Minus 3I plus 5I would be plus 2I. Again, it's kind of like combining like terms. But not exactly the same, since we're talking about just real parts and imaginary parts. Okay, multiplying. One of the main things we need to keep in mind is that I times I is I squared, and I squared is -1, because I is the square root of -1. So for here, we would be multiplying just kind of straight across the 8 times the 5 there. That would a -8 times 5, so that would be -40. And then I times I is I squared. And then I squared is -1. So we can write that as -40 times -1. And then a negative times a negative is positive. So that would just be 40. It's same idea here. We're going to multiply, but we're going to distribute first. So we're going to multiply the 6i times the 8, and then the 6i times the -3i. 6 times 8 would be 48, so 48i. And then 6 times 3 is 18, so minus 18. And then I times I is I squared. I squared we know is -1, so we've got 48i minus 18 times a -1. Well, negative times a negative is positive, so that's going to be plus 18. So 48i plus 18. Next, we'll look at multiplying